Algebra 2, very first video of the semester. Okay, welcome. Here is Unit 1, Day 1 video. Here are your notes. Unit 1 has a lot of review from Algebra 1, so hopefully this looks familiar to you and you will be able to get these concepts down comfortably if you don't already have them. So let's get right into it. Graphing vertical and horizontal lines. We are going to first graph this line. It's listed here with a set of ordered pairs on the left. They gave you some XY coordinate pairs, and we'll take the first point, which is -2, -3. So if we go left 2 units and down 3 units, should be right about at that point right there, right? The next point that we have, -2, -1. Your second point coming in at that spot, -2, 2. So left 2 and up 2. And then finally, they give us -2, 5. So we want to go all the way up to 5. There we go. So since this is a line, we are going to connect our dots. Lines extend forever in 2 directions. So what did you notice about this line? Well, it is vertical. And if you look at the ordered pairs, you should notice that every single x coordinate is -2. So the equation of this vertical line is x equals -2. And if you go back to your Algebra 1 days when you were probably taught Hoy-Vux, this part right here, the VUX vertical lines, that's the V, have undefined slopes, that's the U, and their equations always look like x equals a constant, like this. That's the x. So in Hoy-Vux, that's what VUX stands for. Vertical lines have undefined slopes with x equals a constant. So let's change our color up here, and let's take a look at the second line. Okay? The second line has the point -2, 3. So left 2 and up 3. Has the point 0, 3. Has the point 2, 3. And it has the point 4, 3. Okay, we connect the dots. Okay, and now as far as the line, the equation here, hopefully some of you, if not all of you, have kind of figured out, oh wait, this was a horizontal line. Horizontal lines have a 0 slope, and they have an equation of y equals a constant. Well, if you look at this table, you notice that the y coordinate is always 3. So your equation here is going to be y equals 3. Okay? So that's the Hoy part in Hoy-Vux. Horizontal lines have 0 slope. Y equals a constant is going to be your equation of the line. Okay, let's move down the page just a bit. I'm sure that you heard y equals mx plus b at least 100 times when you were in Algebra 1, maybe even a little bit in geometry. So y equals mx plus b is called the slope-intercept form of a line because the m represents the slope of your line, the rise over the run, the steepness, the incline, the slant. The b represents the y-intercept, which is the point where your line intercepts the y-axis. Positive slope rises to the right. Okay? Remember, we always go left to right, just like when you read, we read left to right. So it's like you're going uphill. Negative slope goes down or falls left to right, going downhill. Horizontal line has zero slope. Vertical line, slope is undefined. And okay, so maybe you like to utilize the slope dude. Slope dude is skiing up and down slopes. So he's working hard to get up the slope, because remember, we always go left to right. So he's going up the slope, that's why it's puff, puff, positive. And he's going downhill and it's easy and it's nice, negative. And then he has to work cross-country skiing. And he said, this is zero fun. It's like zero slope. And then he gets the vertical part and he's toast. And that's undefined. Okay, so if you needed a little extra help to memorize those, feel free to use the slope dude. Okay, now to the last page. Okay, I know this is a little bit, at least it looks a little bit fuzzy on the left side, so I'll read what it says here. The first equation says y equals x plus 9. Okay, so y equals x plus 9, and it's asking us to identify whether this is linear or not. Okay, is this a linear equation? Okay. So, linear equation, yes, this is. This is actually in y equals mx plus b form. Okay, don't forget y equals mx plus b from the previous page. The second one, y equals negative 3x cubed, or x to the third power. Is that linear? So there's an x cubed, x to the third. Right? Because mx plus b has an x that doesn't have an exponent written, it's like invisible math. The exponent is 1. Okay? You don't have to write it. It's like saying 1x and x is the same thing. X to the first and x are equivalent. Okay? They're the same thing. They mean the same thing. So if you have x in your equation, it must be to the first power for you to have a linear equation. Okay, so let's finish these last two. This is y equals x squared plus 7. Because it's x squared, we have a great big no. As a matter of fact, if you graph this, it's a parabola, as many of you know, I'm sure. And then this last one is y equals 4 to the x. Now, anytime you have x in the exponent, it's not a line, okay? You graph this if you want on a graphing calculator, and you'll see it's definitely not linear. It's not a straight graph, okay? So, conclusions. Well, what can we say about our conclusions from these examples? Well, first you can say that x must have an exponent of 1. Okay? In your equation, if there's an x, 1 is the exponent. Second thing that we just looked at is that if there is an x or any variable in the exponent itself, it's not linear. Okay, so those are examples that go with your conclusions. Okay? Now, linear as far as your ordered pairs. If I just give you, instead of the equation, if I just give you an XY chart. Okay, so let's look at this one on the left first. Okay, notice that we increase the x coordinate or the x value every time by 1. Okay, so the x value is going up constantly by 1. So we'll say +1, plus 1, and plus 1. Okay? So you're adding 1 to each x. So let's see what you're doing to the y coordinate. From -4 to -5, you're subtracting 1, or you're adding -1. From -5 to -6, you're also subtracting 1. From -6 to -4, you're adding 2. Okay, so because we had consistent adding 1 for the x's, and you had almost consistent but not quite, we had an inconsistent pattern with the y's. This one is not linear. Okay, so we would say this is not a linear graph. And if you plotted those points, you'd see that you got 1, 2, 3 of them that are on the same line, and then you'd have one of them that would be off a little bit. Okay, so let's look at the second one, the one on the right here. So we're going +3, we're going +5. Okay? Let's see what happens here. +3, +5, +3. Oh, look at that, +5. So this one is linear. If you remember in Algebra 1, we looked at the change in y, y2 minus y1, over the change in x, x2 minus x1. That was slope, okay? So if the slope is consistent, in this case, it would be a 5/3 slope. Then consistent slope means you're gonna have a linear graph. Okay, so this is linear. So change in y over change in x, or slope, is consistent for every pair of points, okay? From the first 2 to the last 2 and all in between, it's always going to reduce to the same rise over run, okay? And then obviously if you plot them on graph paper and connect them with a straight edge, you will also see that they are linear. Okay, so that's day 1 notes. Hopefully you are going to be able to confidently go after your day 1 practice. If you have any questions, feel free to either message me in Google Classroom, send a question to my school email. You can ask me to add you to a flex period coming right up. If you want to Zoom during that time, or if you are in person and you want to come in during flex period, you just have to touch base with me there and we can take care of that. So anyway, that's it for the first video. Okay, here's to a bunch more.